Welcome to Formula 1 Maths. This is exercise 10.2 GCE A-Level Applied Maths, Year 1. This exercise is on forces as vectors. We've got 3 questions to answer. Question 1. A force F equal to 9I plus AJ newtons acts on a particle on a bearing of 135 degrees, where J is assumed to represent the unit vector due north. A. Find the value of A. B. Find the magnitude of the force F. So let's draw our diagram. So looking at the cardinal points, we've got north going this direction and east that way. That means west is over there and south going down. But we don't need the west and the south. We also told that J is assumed to represent the unit vector due north. So let's put that in. Have J going this way. Therefore, I will be that way. Let's now put in our force, F. And this will be on a bearing, as we are told, of 135. That means the angle measured from north will be 135. We can now put in the components of our vector F, and that will be 9I and AJ. To enable us to find the value of A, we need to calculate the angle here, theta. And because this angle here is 90, we can find the value of theta by subtracting 90 from 135 to get 45. So angle theta is 45. We can now proceed to find the value of A by using SOHCAHTOA. According to SOHCAHTOA, tan 45 is equal to the opposite, which is A, over the adjacent, which is 9. So solving for A, we're going to get A is equal to 9 times tan 45. But tan 45 is 1. And so A becomes 9 times 1, which is 9. So the value of A is 9. For B, now that we know the value of A, we can write our vector F fully as F equals to 9I minus 9J because of the direction of A here. It's going to be negative. We can now use Pythagoras theorem to find the value of the magnitude of F. The magnitude of F can be written as this over here. So the magnitude is equal to the square root of 9 squared plus minus 9 squared according to Pythagoras theorem. So if we've evaluated, we're going to get square root of 81 times 2, simplifying, yields 9 root 2 newtons. Question 2. Two forces, F1 and F2, act on a particle. Given that F1 is equal to minus 7I plus 2J newtons, and F2 is equal to AI and 2AJ newtons, where A is a constant. Find the angle between F2 and I. The resultant of F1 and F2 is R. Given that R is parallel to the vector 11I minus 10J, find the value of A. So let's proceed to draw the vector F2 on the diagram to enable us to find the angle required. So let's put in our vector. And because we are told that A is a positive constant, that's why we can draw F2. By the way, this is F2. So we can draw F2 in this quadrant because positive direction will be that way for the I component and the positive direction will be that way for the J component. So the angle required is theta, shown in the diagram. Let's now put in the component of the force, F2. So we have A in the horizontal direction and 2a in the vertical direction. We can now proceed to use SOHCAHTOA because tan theta will be equal to the opposite, which is 2a, over the adjacent, which is a. That reduces to 2. So that means theta is equal to tan inverse of 2. Tan inverse of 2 will be 63.4. B. Let's find the resultant of F1 and F2. The resultant of F1 and F2 will be obtained by adding F1 and F2. So R will be equals to F1 plus F2. So we have 7, 2, and I prefer writing my vectors this way. So 7 minus 7, 2 is the same as minus 7i plus 2j, same thing. But I prefer the column vector way of writing vectors. And so F2 is A to A. And then if we add everything, we are going to get R to be A minus 7 and 2A plus 2. But we are told that R is parallel to 11i minus 10j. So let's suppose this vector here is that vector 11 minus 10. Any vector parallel to this vector will be something like that. And that will be represented by some constant lambda times the same vector. So the length and direction of this vector depends on the value lambda. If lambda is negative, then the direction of this vector changes and the arrow points in the opposite direction. If lambda is bigger than 1, then the length or the magnitude of this vector will be bigger than this one here. If lambda is less than 1, between 0 and 1, then the length of this vector will be shorter. So any vector parallel to this vector will be represented by lambda times the vector, and lambda being a scalar. So because they are parallel, we can say that R, which is this, is equal to some scalar times a vector. From here, we can generate two equations and solve them simultaneously for the value of A. So the two equations will be, the first one will be A minus 7 is equal to 11 lambda, and the second one will be 2A plus 2 is equal to minus 10 lambda. Now we can proceed to solve the equation simultaneously by multiplying equation 1 by 2 to obtain 2A minus 14 is equal to 22 lambda, and then subtracting equation 2. So if I do that subtraction, I'm going to eliminate A and obtain minus 16 is equal to 32 lambda. Solving for lambda will yield minus a half. So it means that the vector R is in the opposite direction of this vector here, and the magnitude is also smaller than the magnitude of this vector. So we can now go and substitute lambda into any of these equations to find the value of A. It's easier to use equation 1. So we are going to substitute in equation 1, and we are going to get this. Solving for A, simplify to get A minus 7 is equal to minus 11 over 2. And that will be A is equal to 7 minus 11 over 2. And solving will give A is equal to 3 over 2. And so that is the value of A. Question 3. Three forces, F1, F2, and F3, acting on a particle, Q, are given by F1 is equal to minus 10 minus 7, F2 for 3 newtons, and F3 AB newtons, where A and B are constant. Given that Q is in equilibrium, A, find the values of A and B. B, the force F1 is now removed. The resultant of F2 and F3 is R. Find the magnitude of R, the angle to the nearest degree that the direction R makes with the horizontal. Now we are told that Q is in equilibrium, so it means the resultant force acting on Q will be equal to 0. So that means that F1 plus F2 plus F3 will be equal to 0. And then we can solve that to obtain the values of A and B. So if we substitute our vectors, we're going to get this. All we do now is solve for A and B by using vector algebra. We will take this to the other side and this vector to the other side. And if we do that, we obtain this. Because this is positive over here, it goes over there, it becomes negative. And this is positive, it becomes negative. Now we can multiply this negative into this vector because this is like a scalar with a value of minus 1. So minus 1 times minus 10 is 10, and minus 1 times minus 7 is 7. So we obtain this. Now if we solve, we're going to get 10 minus 4 and then 7 minus 3, which will be 6, 4. That means A is 6 and B is 4. So those are the values of A and B. Now we can go and find R because we now know F3. So the resultant of F2 and F3 is R. That means we add them. If we add them, we are going to get 10, 7. So 10I plus 7J. We can now find the magnitude of R by using Pythagoras theorem. And that means the magnitude of R is equal to the square root of 10 squared plus 7 squared. That gives square root of 100 plus 49. And evaluating gives the square root of 149. This is a horizontal direction. So let's put in our vector, which you now know as this. So now R is that, and the angle we are looking for is theta. We can use SOHCAHTOA to find theta. But before we do that, let's put in the components of R. So the horizontal component is 10I, the vertical component is 7J. So tan theta will be equal to 7 over 10. So theta will be equal to tan inverse of 7 over 10. And that will be equal to this. Oh, that's not right. So that is not right. Sorry for this. That would be, according to my calculator, will be 34.99, and to the nearest degree as required will be 35 degrees. And so that's the correct answer. Thank you again for watching, and I'll see you in the next video.